Hi, thank you so much for inviting me to speak here. It's exciting. I love it every time I get to come to the Netherlands. I actually live in Atlanta, Georgia, in the United States, so please forgive my Georgian accent. And I also want to do a shout out to the mixed reality user group that's just outside the door. I brought 2 Magic Leaps with me from the United States and handed over to them. So if you'd like to check out the Magic Leap, they've got it, and they also have several HoloLenses. So my name is James Ashley. I'm a developer with a really long history with this sort of technology. I started off probably around 2010 when the Kinect came out, hacking that. In 2012, I wrote a book called Programming the Kinect, which was not the best book on the Kinect, but it was the first book on the Kinect. So it ended up selling out over all the others. After that, I was in the Kinect MVP program, which is a Microsoft special thing that gives you insider access, and it was very cool for a long time. And while I was in that, we discovered that the same team that developed the Kinect was going to end up developing the HoloLens also. It's probably 2015. And at that point, we were really excited, especially because the Kinect 2 had totally dived at a certain point. Following that, I worked with Dennis, who's heading up this whole conference, and we did a LinkedIn Learning course on the HoloLens, which was an incredible amount of fun, out on the beach in California for a week. And then finally, out of all of that, this is a really weird thing. I live in Georgia. Another company in Georgia was going down to Florida to visit with a mystery company that ended up being Magic Leap, and I ended up getting a really huge head start in their private developers program. So I did that for several months before the Magic Leap was finally launched. And in addition to that, I got a chance to enter into the grant program with my company, which does architectural visualizations. And it's a totally separate thing. It's 2 different ways into Magic Leap. And we ended up being given a very large grant by Magic Leap to develop applications for the device that would showcase the device. Anyways, and I'm also an MVP. And these aren't my words, these are Scott Guthrie. It's what he thinks, I don't know. But I'm very proud of it. We're basically experts that don't have to always kowtow to everything Microsoft wants, but are able to give our independent opinion about the technology. So I feel like I'm in a fantastic place. I love it, where I get to look at the HoloLens and be honest about it. I get to look at the Magic Leap and be honest about it. And it's just a fantastic world. And pretty much 10 years ago, I never would have imagined I could have gotten into this place, except I kept falling backwards into some really cool projects. So the first thing I want to do is give you a very, very quick history of mixed reality and where it all comes from. And we can start off with gaming. Mixed reality really starts at a certain point with Kinect. And it was the first Kinect that came out of Microsoft, and it ended up being an internal project initially. And they wanted a peripheral device for the Xbox that would let you be a controller. So one of the key features for that was skeleton tracking. And one of the names nobody really knows is Jamie Schotten, who actually figured out all the technology back in 2009, basically, to make this happen, to do the skeleton tracking. And it required really advanced algorithms, stuff that he knew about machine learning. And additionally, it required other parts of Microsoft research that was basically linking computers together so you could do massive programming. Sort of the whole thing that you do with Kubernetes today, they had to do from scratch. The other thing that was fantastic about that was it's probably the first time that Microsoft Research actually made money for Microsoft. They were getting $8 billion a year just to do free research. And suddenly they had this example where all this fantastic research actually came back and developed something very cool. And that changed a lot of processes internally at Microsoft. But it also kind of kick-started a lot of the AI work that's going on today that all starts with research. Okay, so in that first Kinect program, there was another person named Alex Kipman who rose through the ranks, became the leader of the Kinect project, and eventually became a master of the universe and developed the HoloLens and was given a big budget to do all these things. Meanwhile, in Mountain View, California, you had Google Glass coming out around 2013, 2014. So a bunch of things happening all at once. And meanwhile, in Plantation, Florida, starting about 2010, you had another company with Rony Abovitz, who's trying to do his own augmented reality glasses. And this is a really early prototype that was massive and bolted down to a table. Okay, so here's a general unified theory of how mixed reality works. My idea is that there are two kinds of engineers in the world. They're the ones who like Star Trek, and they're the ones who like Star Wars. And this is really important. I can even prove this. And I'm basically going to say that Microsoft is always Star Trek, and Magic Leap is Star Wars. And the difference is people who like Star Trek tend to be very engineering. They want to solve all the problems and have good resolution within a 1-hour TV show. That's how engineers think in that way. But there's another set of engineers that try to see the big picture, whether there's a big picture or not. They want to find the myth and the story and get a happy ending or a sad ending, some sort of ending. And those are the Star Wars people. And Rony Abovitz is very much a Star Wars person. Here's my proof for this. So all the people in technology today, all the major players, Tim Cook, Jeff Bezos, Sergey Brin. Anyways, they're all men of a certain age, right? It's very peculiar. Somehow they all rose through the ranks and now they're running Silicon Valley. They control the world's economies. They control all of your data. It's kind of fascinating. And they sort of range between the ages 34 to 58, mostly tending on the higher side. Now, Jean Piaget had a wonderful theory about childhood development, about the different stages that you go through. And one of the remarkable things is that there's a certain age from 2 to 7 where the mind is very mythic and is very impressionable. That's when you absorb the most about the world. You lose it a little bit, but it continues from the ages of 7 to 11. And after that, you sort of become an adult and start thinking like an adult. So anything that happens in that range between the ages of 2 and 11 are fantastically important. Now, if we map this to the history of science fiction movies, here's what we discovered. And I've outlined the important years in red. And you'll notice that Tim Cook, Jeff Bezos, and Satya Nadella are too old. They'll talk about sci-fi movies, but they don't really love it. They don't care. But then the important guys are the Star Wars people who watch Star Wars between the ages of 2 to 11 or so. So that's Rony Abovitz, Sandra Pichal, Sergey Brin, Larry Page. And then the next generation is going to be Alex Kidman, who grew up watching Star Trek, because that's the age range he is. And then you've got Mark Zuckerberg, who, of course, watched Terminator 2. It makes sense, right? So that's my proof that there are Star Wars people and there are Star Trek people in engineering, and we know who they all are. Okay, so again, about the history of it, in about 2017, Microsoft had already come out with HoloLens. They were expecting Magic Leap to come out with some device, because Magic Leap kept saying, we have this great device, and you know it because we do these animations of whales, right? What more proof do you need than that? Except nothing happened. So Microsoft would keep delaying their version 2, and in the interim, they came out with a device called the Windows Mixed Reality device, which was really confusing because they also called their HoloLens device mixed reality, whereas this is really virtual reality, but they wouldn't call it virtual reality, they called it mixed reality. And that gets us to August of 2018. So after years and years of delay, and getting to the point where the villagers were finally getting angry, right? Magic Leap finally had their conference and released this device. And the funny thing about this is I've met former employees at Magic Leap who worked there back in 2017, and they would always say, yeah, I never saw anything. I don't know anything about it. And yet the people who worked on it since 2018 are all about this device. I'm not really sure what happened there. There's some great features in the Magic Leap that are not in the original HoloLens. One of them is a 6-DoF controller, and it's actually using radio waves and magnets in order to track the device. So 6-DoF basically means the first 3 DoF, degrees of freedom, are, I know the 3 dimensions of where the device is pointing relatively. 6-DoF means I also know its absolute position or relative position to me, again, based on these magnets. So that's a fantastic thing. And who here is familiar with the original HoloLens? Awesome, that makes the talk so much easier. I can just compare. So there are 2 interactions in HoloLens, right? You get to do this, and you get to do this. And this is really fun, and this is really annoying. So having the controller is amazing. Yeah, I can't say enough good things about it. Eye tracking. This is really weird, but the Magic Leap is also flashing IR against the eyes and has cameras facing inwards. They're tracking those flashes and doing machine learning analysis on the pupils to figure out where you're looking. So the first thing that really provides you is it gives really good calibration of the eyes, which is important with any of these devices. Beyond that, it's hard to say what it's for, right? But it's really cool. This is, to me, the most important feature of the Magic Leap, that the battery is 30 times bigger than the one in the HoloLens. With a bigger battery, it provides certain things, such as you can run the GPU at full force, whereas if you have a low battery, you got to be so careful about using the GPU, right? You want to dial it back. The other important thing, because both the Magic Leap and the HoloLens are using time-of-flight cameras to do spatial mapping of the room, with a bigger battery, you can run that a lot more often, which gives you a much better spatial map, which is what we've discovered with the Magic Leap. It has much better spatial maps than the HoloLens does. And you're probably wondering, how does the battery play into that, right? Because didn't the Kinect always do that and it was always on? So the thing we always have to remember is the Kinect was constantly plugged into the wall. That's why it could scan the room all the time. You could leave it plugged in all the time. These devices are not. They're meant to be untethered. You never plug them into the wall when you're using them, really. So battery life is hugely important in these cases. So with 30 times more battery power than the HoloLens has, that's a lot more battery that can be devoted to scanning the room all the time. The downside, though, of course, is you've got this really massive, heavy thing that you're situating on your waist. I think it's a good trade-off. I think it's a good engineering choice. But there are definitely problems. The other thing that the Magic Leap has, which is kind of crazy because it's kind of hard to see how to use it or when it's in effect, is there are multiple planes of focus. So the HoloLens has a fixed plane of focus at about 2 meters, right? That's where the eyes are comfortable looking at objects. The Magic Leap has 2 different planes of focus. They will not say what the planes of focus are. I've asked many, many times. But the best guess is it's probably around 1.5 meters and a little over 2 meters. And you don't usually see it, but there are certain applications, such as a calibration, where you notice it actually happening, and it's the strangest effect to actually see these objects change planes on you. It's like watching 3D, except 3D suddenly has another dimension there that you didn't know about. It's kind of cool. Larger field of view. The Magic Leap actually has twice the field of view of the original HoloLens, depending on how you measure field of view. It comes in at 30 by 40 degrees, and the original HoloLens was about 29 degrees by 17 degrees. And that actually makes a big difference. It's still small, but it's much nicer. Okay, so I want to do a real intermission now about the term mixed reality, because the term mixed reality is really confusing. We know from Microsoft, they came out and started using mixed reality originally. And Magic Leap started with mixed reality also. They went on and started using spatial computing for a while, but they're back to mixed reality. In the meantime, Microsoft took the term mixed reality and then started applying it to the VR devices too, which is really confusing because originally mixed reality was supposed to mean it's like AR, but it's not AR because it's so much better that we refuse to use the term AR. It has to have its own word, mixed reality, right? Except Microsoft was in a bind where they had to sell this whole concept of mixed reality, but they didn't have the next mixed reality device, so suddenly they changed what they meant by mixed reality. Even weirder is when they developed these VR devices, they called it Windows Mixed Reality, which is still confusing because the HoloLens also runs Windows, so that's also Windows Mixed Reality. So the only way to differentiate between the HoloLens and these VR devices that have no specific name is you call them occluded Windows Mixed Reality devices, which means you can't see through them, right? So that's the basis of this device. You can't see through them. You're missing something that you have in the HoloLens. So at this point, it's really confusing about what term we're supposed to use for this class of devices when we actually understand what the devices are. It's a HoloLens, it's the HoloLens 2, and it's the Magic Leap. It was the Meta before the Meta dived and is defunct. It may be the new Apple device that comes out in 2020. So there's this class of device, and it's not clear what we're supposed to call them, but we'll figure it out like we usually do. So then we move on to the HoloLens 2. This was just announced at the Mobile World Congress. And it was cool. It really was cool. But they didn't really have a release date either. So it was an announcement that didn't really announce when something would be released. Most of the stage show was canned, so we don't know what the device totally does. But we know what Microsoft is saying it's going to do. They did put out a pre-order page, and people have discussed that. One of the problems with the pre-order page, is that, first of all, in a lot of countries in Europe, you can't use it at all. But if you happen to be lucky enough to be in a country that can actually access this page and try to do a pre-order of the device, you're not actually pre-ordering. Instead, you're on a phone list, and somebody will call you and tell you that they'll call you back a month before the devices actually get released. And at that point, they'll decide if they put you on the pre-ordered list or not. The really cool thing about this design, though, is that they've moved the battery from the front of the nose, which was really horrible. I would get sinus pains from wearing it more than an hour, and really strange red marks on my nose that sometimes wouldn't go away. But they moved all that to the back, which means the battery is now at the back of the head. It's better balance. I'm guessing it means a bigger battery. But from the reports so far, the weight of the new HoloLens is very similar to the original HoloLens. And comparing that, say just holding HoloLens in your hand compared to holding the battery pack for the Magic Leap, this seems much heavier. And if the weight is the same on the HoloLens 2 as in the HoloLens 1, that makes me think that maybe the battery isn't that much bigger, which would be troubling. It would sort of limit what the device can do. But there's no saying until we all get a chance to try it out. But that's one of the main things I'm concerned about. The basic specs, I'm so grateful for the large screen because you can mostly read what's going on. The price differences, the original HoloLens was $3,000 or $5,000, depending on whether you wanted a warranty or not. The Magic Leap one is $2,300. Best guess for most people is the hardware on the Magic Leap costs more than they're selling it for, right? Because they just packed it with sensors. HoloLens 2 is advertised at $3,500, but you can pay more if you want to. And if you pay more, you get a subscription to Microsoft Dynamics 365. OS, Windows, Android, Windows, field of view, 29 by 17, and then double for both of the new devices. So the Magic Leap 1 and the HoloLens 2 have relatively the same POV. Resolution is actually identical on all devices if you take into account the greater field of view. Depth sensor, time of flight, time of flight, time of flight. Display type, this was really a big deal. The HoloLens 1 uses LCOS. The Magic Leap 1 uses LCOS plus waveguides, and then the HoloLens 2 uses MEMS plus waveguides. So the difference is LCOS is liquid crystals, which is what most displays use today. MEMS is a technique where you're shooting lasers, and they hit mirrors, and the mirrors will distort in order to give you various effects, including slightly more blurriness, but apparently also the wider field of view, which is good. And that's all I know about LCOS versus MEMS. It's very confusing. Hand gestures. One of the big selling points about the HoloLens 2 that they've been advertising is that they're going to be using a lot more gestures and direct manipulations. We know that HoloLens 1 had 2 gestures, this and this. The Magic Leap uses 9 different gestures. And then the HoloLens 2 just so far sounds like it's going to be amazing. Underlying comic book technology. For some reason, it was important that all these developers of these devices make up their own technology for this. So Microsoft calls their technology light engines, and Magic Leap calls their technology light fields. And no one knows what happens if a light engine runs into a light field, but I'm very concerned about that. So just try to keep them apart. Controllers, HoloLens had a click. The Magic Leap 1 has a 6-DoF controller. But the HoloLens V2, from what we've seen so far, is emphasizing direct manipulations. So This is a gesture thing worth knowing about in UX. A gesture generally is a form of communication. You perform a series of poses, and something intelligent recognizes that you made a gesture, and then it interprets that as something it needs to do, right? So this is a pose, and this is a gesture, and you can always program something to recognize it and act on it. Now, direct manipulation is different because that's actually grabbing a digital object and moving it. It's a very natural thing, and it's immediate also. So that's the basics of gestures versus direct manipulation. And the HoloLens 2 is using direct manipulations as their main form of interaction, and they don't have a controller. Hand tracking. So the HoloLens 1 has some hand tracking that was in a research build for a while. I think it's in the main line, but I'm not sure anymore. Magic Leap 1 supports 2 fingers. No, actually 3 fingers. It does this. Yeah. And 3 joints on each finger. And the HoloLens 2 is supposed to have fully articulated hands, which is really fascinating. You'll be able to do a lot with that if it's actually recognizing all the joints on all 5 fingers. And then finally, the processing unit. As we all already went over, the HoloLens 1 puts it on top of your nose. The Magic Leap puts it on your waist or in your hand. And the HoloLens 2 is putting it at the back of your head. So people are calling that the man bun of technology, right? And do you wonder if the batteries on the back of your head is going to get hot, right? What does that do to you? Or what happens if you sweat? So again, all things that we're going to find out. The underlining core. So this is really important. They're using 2 basic sets of basically integrated systems that include chips and GPUs and so on. And the really cool numbers are, of course, the HoloLens 1 used an Intel chip, which was x64, but they ran it at x32, or at 32-bit. Magic Leap 1 uses a 64-bit core, and it uses the NVIDIA Tegra. X2, HoloLens, the new HoloLens, uses a Qualcomm Snapdragon 850. So the big trick is, how do you compare these 2 things, the Qualcomm and the Tegra X2? So I have this picture of the switch at the top, because actually the switch is running on the Tegra X1. If it's running on the Tegra X1, we can sort of assume that X2 is a step beyond that, right? So what you get in the Magic Leap is a complete system that's slightly more powerful than the Nintendo Switch. It's a good point of comparison. The Qualcomm Snapdragon is running an 850. The 850, to my understanding, is very similar to the 845, which is a mobile device. And the 845 was roughly comparable to the X1. So again, we have 2 devices which are pretty much on par. And that's what you can sort of see across the board. The new HoloLens 2 isn't really a huge jump on the hardware side. It's fairly similar to what the Magic Leap is providing. So the expectation then is where the HoloLens can really make an advance is with the engineering and with the machine learning that's on board, because those are totally Microsoft strengths, because they have Microsoft research, which goes, again, all the way back to the Kinect days, that really strange and interesting and powerful relationship between Microsoft research and this team that works on the Kinect and the HoloLens. We'll go on. Okay, some more about the HoloLens 2. Oh, and one more thing. So one of the problems about dealing with all these technologies for so long is I don't know what people are interested in anymore. Like, if I had my druthers, I would spend half an hour just talking about the different programming models for instantiating spatial mapping in each of these devices, which is super interesting to me, but I think is interesting to nobody else. So at any point, if you have really pressing questions, this is a good time to start asking them, and I'll do my best to answer it as we go along, anytime. So this is something that Microsoft's been putting out to advertise their new gesture system. It looks really cool. It's a direct manipulation. This is a fantastic way to interact with things. The Meta device, which is now defunct, also did a lot of work with direct manipulations. It wasn't very good, but it was cool that they attempted it, because one of the follies of the HoloLens 1 was everybody always wanted to do that, right? It was always the problem with the click when you would watch a new user use it. You'd see them try to reach out and grab these things, and they couldn't. And there's nothing more frustrating in UX where you have an expectation and it's foiled. So they've come back around, and what they're promising is this. But then again, you also notice this isn't a live shot at all. This is something that they've done in post-production. It's special effects. So hopefully it performs as well, but who knows? So the big question, I'm just going to check my time. Perfect. What should you build if you were really interested in developing for mixed reality at this point? And it's an important question. I don't know where you stand right now. I think for major investors, there's a lot of money being poured into this, but the best description of mixed reality is it's a binary choice. It's either going to go really big and be hugely successful, or it's going to fail spectacularly, and there's no real in-between. So if you jump in, you really do have to jump in with both feet and be willing to play it for the long game. So a lot of companies basically have held back and not done that. Other companies had started off jumping in with both feet and then pulled one foot out, right? Laid off half their developers and decided nothing's really happening, we're gonna wait for a while. And the same thing is happening with anybody who's in this field who's worked with major corporations. They've all said, this looks so cool, it's really interesting, but we're gonna wait 2 years, right? That's always the solution to major new technologies that other people haven't adopted yet. Let's just wait a while. And it's been 2 years. This is sort of the time where those companies are coming back again and taking a second look. So again, what should you build if you want to build something? So the great thing is there are very few people in the space, major companies, and it's really hard to get together the right developers and the right designers to do any of these things. But the low-hanging fruit inside of mixed reality at this point is AEC, which is architecture, engineering, construction, healthcare, warehousing, and especially warehouse wayfinding, training, and Microsoft's Dynamics 365 guides is what they're calling it, really plays to that. And finally, data visualization. So AEC, this is the world I'm in now. And part of the reason AEC is really low-hanging fruit is we've watched so many movies where you have digital buildings that everyone assumes that we already have this, right? We don't already have this. Nobody's finished doing this yet. A lot of people have tried. There are a lot of prototypes, but no one's done a complete app. And what this will provide people is not only a more interesting way of looking at a city and looking at buildings, but also the way buildings are organized now. There's a lot of money that goes into construction, right? $40 billion a year. Part of that is just the construction. There's another 40 billion or so that goes into the maintenance of buildings. It's a huge industry. And if you're ever doing new technology, it's really useful to pick wealthy industries and not poor industries. Just to give an example, when we used to work with surface tables, my company would work in retail because there was a lot of money in big box retail. A lot of our competitors would work in museums because there was a lot of work in museums, but there was no money in museums. So the great thing about this industry is there's a lot of money, and they already expect this to be done. So there's an appetite for it and expectation. And what this provides that other ways of looking at blueprints and CAD drawings don't, is an easy way to visualize the data because everything about the building has data built into it already. And all you have to do is find a way to display that for people. And that would be transformative. Healthcare. This is from the movie Prometheus. I just really love it. I'm not sure we'd be using it this way. The more common ways of thinking about healthcare is, for instance, in the surgery room where you have to have a clean room. The HoloLens was great for that because it was passively cooled, so it was never blowing air into the room. And the problem for surgeons is they have to access data. Surgery is very complex these days. There's a lot of information involved, a lot of things that have to be looked up. And if they can access data without actually touching anything, that's pretty exciting. The next level, and this is a space that various people are in and still tricky because spatial mapping and tracking are sometimes inconsistent, is what if you had guides when a surgeon is doing an operation that tells them exactly where a certain screw goes into the knee, right? Why would that be useful? Well, it's useful for insurance companies because they know that you can do it quicker and more accurately than you would without some sort of guidance system like that. And that means doctors get paid more regularly and they get paid more. So it's a very virtuous cycle for everybody. Better surgeries, better payments, less failures. And that's the sort of thing where there's a lot of promise for mixed reality. Warehouse wayfinding. Amazon's building warehouses all around the world right now as distribution centers. They're not the only ones. Other companies are in the same business. And one of the big problems with doing warehousing is you have high turnover. Turns out that people who work in warehouses don't get paid very well. So after putting in, say, $3,000 of training into a new employee at the warehouse, telling them how to work through the warehouse, where to find things, they may quit after a while, and that money is lost. So the notion here is, again, a guidance system that tells you if somebody's supposed to pick up an item, we actually send arrows around the room or around the warehouse that tells them where to find the item. It tells them the state of the item. It tells them where it needs to go. This simplifies the whole training process and makes training at work more easy to do. This is actually an example done by Stimulant with the HoloLens 1. I just want to call them out because they're a really great company, and they figured it out first. This is an application done by Tactile, which is also an early HoloLens partner. And the notion here is holographic training. Wouldn't it be cool if you could go out into the field and have somebody sort of watching over your shoulder from the home office through your cameras who can tell you what's going on around you and what you need to do? Again, it's a training type situation, but if you're an elevator repairman or a radio tower repairman or whatever, having this extra information makes it easier for you to be successful in your job, makes it easier to watch and train junior engineers to replace the senior engineers. And it includes not only video to help you watch it, but also pops up augmented reality guidance and data to instruct you on what to do. And finally, data visualization. The really cool thing about data visualization is over the years, we keep coming up with new ways of visualizing data, right? You got your Gantt charts, you got your pie charts, you got your other charts. And at each point, we realize that 2D data is nice, but 3D data sometimes shows you a little bit more. 3D data going through time shows you even more information. And what we're always trying to do with displaying data in this way is we're looking for patterns. And we know that the human brain recognizes patterns really well. So the trick is, how do we surface all of our data to show the patterns that you wouldn't otherwise find easily? Doing visualizations in augmented reality will let you walk around the object. So not only is it 3D, but it's also moving in time, and you can walk around it to see it from behind multiple angles. Again, just trying to find a way of finding new patterns in the data. And the extra thing that augmented reality provides is that you can talk to someone about it as you're doing it, because communication is also another way of finding patterns with other people. No one knows if it's going to work, but it's very promising as a way of making us more productive and a way of generating insights into various industries and seeing something that isn't there. So the question of why mixed reality? Again, this is a binary choice. It's really tough to choose what to do. For me, it goes back to something like the data visualizations. There's this promise that we're going to see something that we've never seen before. And if you look at standard software programming, it's fun, it pays well, but most of what we do since, say, 1995 is data entry applications where we figure out new and better ways of helping people type in data and store it off somewhere. And this is a promise of a totally different way of computing, a different way of interacting with our space. And that's mostly what I'm hoping for, that by being in this field, we get a chance to see something new in computing that we haven't really seen before. So that leads to a Q&A. So again, my problem is, I don't know if what I think is interesting to you at all. I've just been doing it for a bit too long. So do you have any kind of question you have? I'll do my best.
It's more of a statement.
Yes.
It is a good idea to have a glass or whatever to our jobs or location or whatever, but we also have a problem with people using mobile phones in the cars.
Yes.
And my biggest concern is that maybe people will use it in their cars if mobile phones will be out.
If only, wouldn't that be awesome? So your
Awesome,
question was,
no,
yeah.
The biggest concern is if you start a game, whatever, like we had with Pokemon Go.
Yeah.
People can do whatever, they can socialize through that, and they can look at pictures, they can chat with each other, speak to each other. There will be cars that drive automatically, of course, but there's always a possibility that there will be an increasing of people died because people didn't pay attention.
Right. So the statement was, the thing about these new devices is it isn't going to repeat the problem with smartphones where people will do foolish things like try to, look at their Twitter while they're driving in their car or Snapchat or whatever, and it leads to greater danger. So one of the counter stories in this space is that basically mixed reality will replace the smartphone. That our problem today is everybody's always looking down. So it's not just that it's unsafe to always be looking down, but it's unsocial. We're training a whole generation of people and even training the older generations to not be as social as they were before, right? To avoid social situations. So the offer with these devices is, and they have to be smaller and they have to be more transparent, a lot of changes have to happen with them, but that they can do everything that a smartphone does today without distracting you by making you look down all the time, that you'll always be looking up, which means you're always more aware. Ideally, they'll be augmenting what you're seeing so that you're given additional information about the world to make you, again, more drawn into the world rather than escaping the world. And so with cars, it would be something similar. It should be something that doesn't distract you, but because you're always looking up and the information is coming to you, you're not looking at it, it may be even safer than what we're doing today. And that's a big promise, and this is definitely one of the reasons Apple's getting into this, that they're seeing declines in their phone market, and they have to hop on whatever comes next. And again, it may or may not work out, but if mixed reality is the next thing after the smartphone, Apple has to be in that space, right? And they're promising to come out with a device late 2019 or sometime in 2020. Yes, sir.
When do you see a consumer-priced device coming up? Like a normal
Right.
being, not people buying $1,200
Yeah.
iPhones.
Yeah, so just question is, when do we see consumer pricing for these devices? They're still very expensive now. $2,300 to $3,500 doesn't seem like a consumer price. One of the side effects of that is both Magic Leap and HoloLens are actively trying to promote themselves as enterprise devices. And it makes a lot of sense. Enterprises can afford devices at that price if it saves them money other places. For the consumer, it's a much tougher sell. I know with a lot of the people in this room who are independent developers, it's a really tough sell to our spouses to spend $2,300 on a device, even if we promise that it's the total future, and trust me, babe, it's gonna work out. As far as when it's gonna happen, I don't know. I think everybody's hoping for volume. If there's enough volume for these devices, then they can start bringing down the price, right? But in order to get volume, they need apps that actually make sense. And that's where everybody's stuck now. Either trying to develop the killer app, or even better, trying to develop the user vertical, like one business model where it just makes a lot of sense to have these devices. Jean-Paul.
User experience and gesture versus direct manipulation. What do you really think about direct manipulation without having any feedback?
Mm-hmm.
Because if it's a gesture, I do not expect a feedback. If it is a manipulation, I expect an
Yeah.
haptic
Yep.
feedback.
Yeah.
In the user experience.
John is asking about user experience, that even if we enable direct manipulations, there's this problem where if you reach out to touch something, you expect to feel it. And it's very jarring not to do it, not to feel something at the UX level. So it's almost as if you're missing a sense, right? You can move things, but you have expectations about how that's going to feel, and you're not getting that. Yeah, it's a total problem. One of the solutions a lot of people play with, and this is based on a paper that came out around 2016, I think, or even earlier, is using fake haptics. There are certain tricks for doing fake haptics involving sound. If you play a loud sound or a low sound somewhere in the back of the head, you can sort of fake out the sense that somebody's feeling something. This hasn't been proven out. It's just a theory, right? And there are a few prototypes, and everybody goes, it could work. But that's a lot of what people are working with now.
Then to develop the right user experience, it would be even more complex, right?
Yes.
Haptic glove.
So Joseph asks, what about haptic gloves? That's always been a fascinating thing. Why aren't haptic gloves involved in this whole process? Like, we know that this was a problem, right? And the controller on the Magic Leap is really nice, but that's actually a problem too because of the technology they use, magnetic waves. it's not super precise all the time. It can be offset a little. So we've known about these gloves since, was it the Game Boy that had the gloves first? Why don't we just come back with the gloves, right? And even in Minority Report, Tom Cruise had gloves on to manipulate. If it's good enough for Tom Cruise, why is it not good enough for us? I don't know. I really don't. There are various companies that are developing gloves, but so far Magic Leap doesn't seem interested, and Microsoft doesn't seem interested in it, and it might be the price, or it might be the extra friction of having one more thing that you put on. It's hard to say. But yeah, gloves would be kind of cool. Yes, sir?
Are you seeing an increase in enterprise projects? Is the market ready yet?
So the question is, are we seeing an increase in enterprise projects? And is the market softening up, let's say? A little bit. So I would say that after 2016, a lot of people who thought things were interesting but wanted to wait off, we're into 2019 now, where not only have we gotten announcements about the Magic Leap, but also an announcement about the HoloLens 2. And it's not a huge excitement wave, but it's a little bit of an excitement wave. It's a bump. And from talking to other people, it sounds like people are taking a second look about using these devices again in the enterprise. One of the fascinating things is what Magic Leap did, because one of the big things Magic Leap has is a lot of money. That's their superpower. They have a lot of cash that they can spend. And what they did is they came up with a $10 million grant program where they're just throwing money at various groups saying, can you just build something? We'll support you. Because the biggest problem in the industry now is people are not building enough apps. We need to see more apps. We need to see more use cases. And it's not just for Magic Leap. That's just to lift mixed reality in general, right? It's a case where if the water goes up, it lifts all the boats. And so Magic Leap is making that gambit at this point. Microsoft is playing a slightly different game where they're going for a particular sector. They're Dynamics 365 people. And they're hoping that that will pay off too. As a really cool example of fitting into a certain industry, training in manufacturing and stuff, and having that take off. So yeah, basically market softening. There are certain strategies to increase interest in the enterprise, but no idea what's going to actually stick.
How much are the apps interchangeable between Magic Leap and HoloLens?
That's a great question. Is it easy to integrate or port from one device to another? A little bit. So the easy part is everybody uses Unity in order to do development, but the toolkits for each are slightly different. Magic Leap has the Magic Leap kit, the Magic Kit, and then Microsoft has an open source project called the MRTK, which grew out of the Holo toolkit. So at this point, not. But that's also one of the fascinating stories, too. Again, with the notion that all of mixed reality succeeds if the water rises and all boats float, right? Everybody's also working for cross-platform solutions. And right now, it mostly has to do with Apple. Microsoft is working hard to integrate well with Apple's coordinate systems and to support that. Hypothetically, Magic Leap, that seems like low-hanging fruit for them to get that working, too. And that's one of the points of integration that would make things easier. Because Magic Leap is using a private toolkit and Microsoft is using an open source one that they mostly manage themselves, it's kind of up to the community to find a good cross-platform solution. There's a new one called XRTK that doesn't stand for anything. It's just XRTK. And their goal is to build a higher level abstraction that sits on top of both the Magic Leap and the Microsoft HoloLens and the HoloLens 2, so that there will be a common way to develop for both of them, but also extend them. And that's being run by Stephen Hodgson now and Simon Jackson. Just both developers, very talented, but mostly working on their own. So if anybody's interested in helping them, it's a GitHub project, XRTK. Please do, I encourage you. One more? Yes, please.
So you talked about the comparison between HoloLens 2 and Magic Leap.
Yes.
There's another device that I'm wondering if you know in the Project North Star from the guys at Leap Motion.
Uh-huh.
And I wonder if you've looked at it and what your opinion is on the thing.
Right. So the interesting thing about that is, well, two things. First, Leap Motion has the absolute best hand tracking of anything out there. The best hand tracking experience has always been putting the leap motion on top of the Oculus, right? They have 1 or 2 examples where it's just fantastic, where it's in real time, you can grab an object and throw it, and it's completely realistic and wonderful, or at least, compared to every other device. It's as good as it gets. And one of the questions about the new HoloLens 2 is the demos with the videos look really good, but is it actually going to be as good as the leap motion, right? And one reason to think not is the leap motion is actually plugged into the current all the time, and is constantly shooting rays out in order to get the depth information. As far as we know, the HoloLens isn't going to be able to do that because it's running off a battery. So the way to compensate is, obviously, Microsoft has really good AI, and maybe AI will be able to compensate, but we just don't know. To the other question, have I seen this device, Project North Star? No, because it's not really a device. It's more sort of an architecture for a device, right? A design for a device. And I think 1 or 2 people may have been able to put it together, but the problem is the underlying components are so expensive that it's not really something you can do in your own garage. And even some of the components, it's not like you can buy 1 piece from China. You got to buy, 500 pieces from a factory in China to get that 1 piece that you need in order to put this thing together. So yeah, I don't know anybody who's tried it, but it looks cool on paper. Yeah. So I think my time is up. Thank you so much for coming to my session today.